Hello, this is Alan again with a video on another of the ECL built-in functions, this time the normalize function, the second variant of the said function. I think it's best, before we dive into ECL, is to really explain the functionality, as this variant of normalize is paired with another function, denormalize, and I think it's a good idea for full understanding of the functionality here is to show both at the same time. But this particular video, the ECL, I'll just concentrate on normalize. But here's the situation we have. You have an input data set, which is a parent-child relationship. We've got a data set containing addresses and their residents residing at this address. This here ID is just an internal ID that's generated for this data set here. And we want to, let's say we just want the resident information. We want to extract the child information from this overall data set, perhaps also retaining some of the fields from the parent's data set at the same time. So in this particular example, I've not only extracted the child data sets, but I've actually retained information from the parent's data set, basically the ID. And you can see this is completely flat normalized data sets here. The denormalize then is the opposite of that, the inverse function. It's really a specialized join where you have two data sets which are joinable by some condition. In our case, it's an ID field here, to generate out from two data sets a parent-child single data set, which has a parent-child relationship. So the two are the inverse of the other. So going back to normalize here, let's get into the ECL of this particular example I've got up here. Okay, so this is an exact representation of what we've seen in the PowerPoint there. This is a record structure for the inputs. We've got the first name, last name of the child data sets. Then the parent data sets is an ID and address, and and its list of residents at that address. The output record, we just want the ID, the name, and I just want to demonstrate count. It's not in the PowerPoint, but I think when understanding any of these built-ins, it's a good idea to always just shove in counter just to see how it's behaving. But anyway, this inline data set D is just data populated in the structure above, the input structure above here. And normalize itself takes, the first parameter is the input data sets that you want to extract child data sets from. The second parameter must reference the child data set. I mean, you may have multiple child data sets in one data set, so you have to identify which child data sets you're extracting. In this case, it's residents. This is identified as a transform. This is an optional parameter left, which is the reference to the left record. This is a reference to every right record, that every child record in the parent record, and I've just stuffed in counter as well. That's another optional parameter here. So this transform gets called once for every child record in a parent data set. So in the first example, it will get called 5 times. Each time, all 5 times will have the same parent record, but R here will be we'll move on from Anna, Alan, Isabel, Jan, Colin. So there'll be 5 calls of this transform for the first parent record, and the second one will just get called twice. But you'll see this in the counts, because that's effectively a tracing what I've put there. So let's run this and see what we get. Okay, which is really the extracted child data set with the ID retained from the parent record, and I've also put in the count, and you can see that the first the parent record transform was called 5 times for the for each record in the child data set, and for example the last one was only called once, as there's only one child record for ID for that address there. A few things to say about this. You don't actually need to, as I said, the left isn't an optional parameter. If you don't need any information from the parent record, you can just leave it out. So let's just show you that here. So get new dates. So all we really need is the right, and that is a mandatory parameter. So we don't need ID, and we don't need count there, so it's just our name really. And here we've just, so let's just see what we get there. There we are, just the child information. Now there is a shorthand form. You don't actually have to, for very simple transforms, you can do the transform itself can be inline, and I personally find for simple transforms they're easier to read if they're inline. So you don't actually need the body of a transform there. What you can do is the body of transform here. So now the transform's effectively in line. You have to specify the output format. I'm saying self.count becomes equal to counter. Then all the left fields, parent records, set up from the left hand side, and all the child information. Again, there's a field name by field name matching is set up from the right hand side. So in the output, you need ID there, don't we? What was that? ID. There we go. So let's just syntax check that. And again, if we didn't have the field by field matching, so if that was count xxx, it wouldn't like that, because it doesn't know how to satisfy self.counts, because there's no it's trying to satisfy count xx. So let's just remove that error there. Let's just see what we get here. And again, exactly the same information, but we haven't needed effectively a big body of transform. As I said, personally, I find simple inline transforms easier to read. That's about it for the normalize. The next video will be on the twin of this, the opposite operation, the denormalize. All the best.